So, dear friends, once again welcome, and let us discuss about the SFD and BMD for some standard cases. SFD and BMD for some standard cases like cantilever beam, simply supported beam with different loading conditions like point load, distributed load at a mid or somewhere else. So in previous lectures we have discussed about the support reactions, how to find out the support reactions and how to draw SFD and the BMD for the cantilever beam. Now let us discuss about the simply supported beam. The same SFD BMD for simply supported beam. So for that, let us draw the load diagram which I have already drawn to save the time. So here at one end, okay, the end name is A and the other name is B. So at one end, what is this? This is the hinge support, and this is what? This is the roller supports. Support. How many rollers? 3 rollers are there. ठीक, अब देख सकते हैं इट जस्ट लुक्स लाइक हिंज. अगर आप रोलर्स को हटा दें तो ये हिंज बन जाता है. और सपोज ये हिंज बन जाएगा, सो वेदर इट विल बी डिटर्मिनेट और इनडिटर्मिनेट. So it will be indeterminate. Why? There will be 4 reactions, but how many equations we have? We have only 3. ठीक है. So इसका मतलब क्या है? फिर इसको एनालाइज नहीं कर पाएंगे. एनालाइज करना मतलब कि इसका SFD BMD कैसे बनेगा, so that this concept, this analysis can be applied in our real application like construction of bridge. Okay. So इससे एनालाइज नहीं कर पाएंगे. ठीक है. So but here that's why the roller support at one end and another end hinge support, and it is not necessary that always. In many questions we have seen the left side only hinge, right side roller. It is interchangeable. Left side may be roller, ठीक है, right side हो सकता है hinge हो जाए. Okay, so no need to worry about that. Okay, now next is after this load diagram, what is next? So next is to draw the free body diagram. ठीक है. So just take the same length. Here just better to draw a line, the perpendicular dotted line, and from here, from B, draw the dotted line. And this is the beam of length L, and here now support the reactions I'm showing. So it is VA, support reaction VA, and this is also support reaction. हिंज पे कितने सपोर्ट्स रहते हैं? 2 सपोर्ट्स रहते हैं. अगर कोई वर्टिकल मीन्स हॉरिजॉन्टल लोड्स नहीं है बीम पे, so it is equal to 0. If there is no vertical horizontal work in the beam, so HA, horizontal reaction, will be 0. This we know, it is very obvious. Okay, and many times we have discussed. And to remove roller, now we have to put reaction here. ठीक है, directions upwards. ठीक है, because the load is acting downwards, that's why directions of reactions will be acting upwards. Okay, and suppose अब हम क्या करेंगे at mid. This is the mid. Suppose they are giving name. This is A, this is B, at C. C is the midpoint. And before that, what you have to do? You have to take 2 sections. ठीक है, just before and after. So suppose this I am taking and give the name like 1 section, 2 section. Okay, now what we are going to do, we are cutting this. ठीक है, means ये सेक्शन को हटा दिए हमने, ठीक है, एंड इस सेक्शन को हटा दिए. सो इन नेक्स्ट वी आर गोइंग टू डू, let it extend here, here, here. So this is the beam. Okay, and support direction here at A. Whatever the support direction VA here, and this section name is 1 okay, and this is the suppose shear force S, and the moment, suppose we are taking the anti-clockwise. So same for here, ठीक है. ये कौन सा हो गया आपका, ये 2 it is 2 and see shear is downward, so to counter that shear upward, and moment anti-clockwise to counter that the moment now clockwise. Okay, and then RB here we have to show, and suppose from here means from A, it has x1 distance, ठीक है. So now our focus is this free body diagram. This is the free body diagram, and this is with the cut free body diagram. After cutting the section, separating, then we are going to analyze. तो इससे बहुत आसान हो जाएगा, ठीक है. And what about the reactions? So it's the beam is symmetric. So the beam is symmetric, then what we will get, VA is equal to RB is equal to W by 2. Okay. And now we have to get the what is the value of S, what is the value of M. This is M here, this is M here. Okay, so let us do left side. And dear students, it is obvious, due to symmetric, the load it means distributed both side, left side reaction VA, right side reaction RB equally. And this also we can calculate, we can get it, ठीक है. कैसे? By applying Fy is equal to 0, static equilibrium condition, or take moment about any point A or B is equal to 0. Okay, so these are reactions we know. Now our purpose is to get what is S. S क्या है, ठीक है. This we want to know. So how to know that? The same the static equilibrium condition we are going to apply, and see the left side. This is the left side. Okay, it is right side, left hand side, and then what you get, VA. Now यहाँ पर आपको you have to means remember the sign convention, ठीक है. साइन कन्वेंशन में क्या कहते थे, this left side upward positive, this we take positive, and downward we take negative, ठीक है. And means it is left to the section, ठीक है, left to for the left. Okay, so as per this, what will be, VA with positive sign and minus S, ठीक है, is equal to 0, and S is then S is what, S is our VA, and VA is our W by 2. Okay, and this is for the left side. What about left side section. Now the right side, better to do here this side. Right side section. Okay, so this you can say the upward direction, where just opposite we take. Upward means negative, and here the this as is also acting upward, it will be also in just again the sign convention. Yeah, this is suppose section x, okay, and this is left side, right side. So this we take negative, this we take positive. So based on this, our now concentration is here. Here means this section we are going to analyze. Okay, then same what we have to do, fy is equal to 0, then what we get, see rb upward, rb acting upward, so negative sign, and s is also acting upward, so negative, we take negative rb, negative s. Okay, so what will be then, s minus s minus rb is equal to 0, and rb is equal to what, it is w by 2. So what we get ultimately, yeah, s minus w by 2. Okay, so now it is very obvious how to draw the SFD, and वैसे तो ऐसे बिना कैलकुलेशंस के भी आप कर सकते हैं, बट मैग्नीट्यूड इज रिक्वायर्ड, दैट्स वाई कैलकुलेशन इज रिक्वायर्ड. एंड कैसे, लाइक देख सकते हैं हियर एट मिड सम लोड इज एक्टिंग, ठीक है, एंड एंड पे सपोर्ट्स हैं, ठीक है. सो इट विल ट्राई टू शेयर ऑफ, इट विल ट्राई टू कट द बीम एट दिस पॉइंट, ठीक है. तो कट होके क्या होगा, जो पोर्शन एक पोर्शन नीचे चला जाएगा. ओके, सो if you draw the SFD BMD, this is A, B, so as per the लेफ्ट साइड सेक्शन, देखिए आप एस वी ए इज इक्वल टू व्हाट वी आर गेटिंग, दिस वी गॉट, ठीक है. सो ये क्या हो जाएगा प्लस, एंड अप टू व्हाट, जहाँ तक अप टू जहाँ पे डब्ल्यू एक्ट कर रहे हैं, अप टू मिड, एंड व्हाट इज द मैग्नीट्यूड, it is positive shear, and the magnitude is here, this is w by 2, and it is itself VA. Okay, and ये why this is constant, because there is no other load. Okay, in between means A and C कोई भी लोड नहीं है. Okay, at C पे कोई पॉइंट लोड है, उसके पहले नहीं है. Okay, well now for this section A to C, now what about C to B? So we have the shear force relation with the load. Okay, and it is minus, so माइनस है तो क्या करेंगे यहाँ से हम, and magnitude will be same, so here from here to here minus, and magnitude is what, here magnitude is minus w by 2, ठीक है, and it is equal to RB. So SFD we have done, and this is the SFD, shear force diagram. It is shear force SFD. ठीक है. What about the bending moment? Okay. So, however, it is very obvious from the observation. By seeing these, we can get how, like A है, this is B, and it is C. So how it is varying from A to C. ठीक है. And the bending moment at the supports. ठीक है. Bending moment क्या है? Resisting है. ठीक है. Resist करता है. Resisting moment. So at the ends, what will be? आप इसको ऐसे भी समझ सकते हैं, जहाँ पे सपोर्ट्स हैं वहाँ पे फेलियर होने का चांस नहीं है या चांस कम है. ठीक है. सो ए पे सपोर्ट है एंड बी पे सपोर्ट है, तो बेंडिंग मोमेंट क्या होगा? डायग्राम क्या होगा? 0 होगा. ठीक है. और जहाँ पे लोड है, ठीक है, सो वहाँ पे डिफॉर्मेशन होने की चांस रहेगा. सो एट ए एंड बी इट इज ऑब्वियस 0. ठीक है. 0 से स्टार्ट होता है. एंड दिस इज द व्हाट? द लाइन W is constant. Okay, so suppose as what we get, it is equal to W. It is in general case. So M will be what? S multiplied by some distance. Okay, L. W L. Suppose in general case. Okay. So what we get here? The linear variation. Okay. So linear variation means from A to C, and whether it will be positive and a negative. That is also question. So let us calculate the bending moment. Okay, so same left side section here. Left side we are calculating. So summation of M for the section 1 1 is equal to 0. ठीक है. Okay. So see the direction here. Here means now focus here. ठीक है. And see the direction of movement. अब यहाँ पे क्या करना है? M suppose we are taking M anti-clockwise, or the sign convention you have to remember. Better to remember the sign convention. What is the sign convention for bending moment? So like this one we take positive. ठीक है. This will be positive, this will be positive. So that's why here M is acting anti-clockwise. Means this one better, this one. So positive, M positive we have taken, and what about VA? So VA will be in minus sign. Okay, VA multiplied by, and we are taking moment about section A, section 1 1. ठीक है. That's why it is multiplied by now the x1 distance is equal to 0. And better to here what we do, this M is acting the anti-clockwise and this V is acting clockwise. ठीक है. तो यहाँ पे हमें बैलेंस करना है, लेकिन यहाँ पे अगर बेंडिंग मोमेंट का देखें तो ये साइन कन्वेंशन ये ऐसा है. ठीक है. बट हियर वी हैव टू बैलेंस. ठीक है. सो बेटर टू फॉरगेट दैट व्हाट इज द साइन कन्वेंशन फॉर बेंडिंग मोमेंट हियर. Okay, because or same thing if you consider, then also no problem. Okay, because suppose this is acting in clockwise, so obviously this is to balance this left side will be acting the in clockwise. It is anti-clockwise and it is clockwise. ठीक है. So based on this concept we can do. So what we get, M is equal to m is equal to, here we get, and the w va is equal to what? Va is equal to w by 2 multiplied by x1. So m means wx1 divided by 2. Okay, and what about here? Now boundary conditions we have to apply. If x1 is equal to 0, means we're talking about what? 8a. Okay, so m a will be 0. Okay. So what I was trying to say कि end पे due to support there will be no deformation. ठीक है, so it is verified mathematically. And if x1 is equal to the half distance L by 2, you can see here, ठीक है, it is varying L by 2 from here to here. That's why from A to C, ठीक है, means from A to C we are taking. So MC becomes now W L by 2 divided by 2, it is equal to WL by 4. Okay, and what about the right side calculation? Okay, so the same bending moment. Now the bending moment bending moment about the section 2 here ना, आप देख सकते हैं, this portion we are going to study. So it is equal to what? So see here, the moment the sign convention, and the clockwise what we have taken, clockwise whether we had taken positive or negative. So here from this we can get m, here we had taken anti-clockwise negative. So same we have to do, means clockwise minus, anti-clockwise positive, clockwise negative. Okay, so our focus is now here. So this m is acting the clockwise, that's why minus, and RB is acting, this RB is acting the anti-clockwise, so that's why plus RB, and the distance is here what? The distance is here x2, so x2 is equal to 0. So we are getting here, that is RB x2, and RB is what? W by 2, so W x2 by 2. And now boundary conditions we have to apply. Boundary conditions we have to apply, or simply write applying boundary conditions, apply. Okay, so if x2 is equal to 0 means इसका मतलब क्या है? At B we are talking. So MB is equal to, then x2 is equal to 0, then MB will be 0. And suppose if x2 is equal to L by 2, ठीक है? Why? Because this is L, this x means from here to here it is L by 2. ठीक है? Once again, because we are talking about C. ठीक है. So whatever the relation is, we want to extend up to C, and it is L by 2. It is L by 2. ठीक है. That's why x2 L by 2, and from where means in between B2 C. Okay, so what we get at MC? We get same W L by 4. Okay, so here coming to here, based on our calculations, based on observation में क्या था कि at A and B bending moment 0. ठीक है. MA MB bending moment 0. MC the load point. ठीक है. सो वहाँ पे मैक्सिमम बेंडिंग मोमेंट. ठीक है. एंड कैसा बनेगा ग्राफ, कैसा बनेगा? सो ऑब्वियसली व्हाट वी गेट m, that is the linear, and we can see MC what we get WL by 4. Okay, so it is positive value. So suppose this is the magnitude, ठीक है, of WL by 4. ठीक है. Then A to this side we have to match, and from here to here. ठीक है. So this is positive, and it is what this whole figure is for the bending moment diagram. So ultimately, based on our calculations, what is we are going to summarize? This was the beam A, B at C, W ejecting supports was here, VA, and at B, RB. Then what we did, here we take section, here we take section, the name 1 here, name 2. Then from A to this section we have taken x1, from B to this section means section 2 we had taken x2, and the length of beam is L. then क्या किए हमने इस पोर्शन को this portion section, this is the section 1 and this is VA. ठीक है, सेपरेट कर दी, कट कर दी. अब कट करने के बाद क्या shear force we have to show. So shear force we have shown like that, downward acting, and this is M. Similarly, now right side, this is section 2 and this is B, RB. ठीक है, and this is what S. So S just काउंटर करने के लिए, अब बैलेंस करने के लिए ये आपका ये ऊपर S ऊपर, and the direction of M is here anti-clockwise, that's why we are making it clockwise M. ठीक है. अब क्या करना है, इसी को दिस इज द फ्री बॉडी डायग्राम FBD, एंड दिस फ्री बॉडी डायग्राम वी हैव टू एनालाइज. ठीक है, अब एनालाइज करना है तो इसी को बैलेंस करना है. ठीक है, सो लाइक VA acting upward, so this we have taken positive as per the sign convention, as is negative, as here negative, it is acting downward. And what about the moment? So moment like suppose in this we have taken positive. Okay, so what will be this? Due to VA due to VA so it will be what? Negative, nothing else, sign convention. Similarly for the right hand side. Okay, then what we got the shear force ठीक है, मिड पे ड्यू टू फोर्स क्या करेंगे, इट विल ट्राई टू स्लाइड, ठीक है, एंड from here to here it is the constant value, and a plus due to calculation we got this, minus due to calculation, no, from the calculation we got, ठीक है, and what is the, this one is what, this is actually VA, this is actually what, it is actually RB reaction, okay, and you can say this side and this side, this side and this side both are same, okay, this side and this side both are same, ठीक है, and VA is equal to W by 2, RB is equal to W by 2, due to symmetry भी कर सकते हैं या from the calculation also, ठीक है, and this is the our SFD. What about the bending moment, ठीक है, so bending moment, this is C, A and B, what we got, we got MA and MB is equal to 0, ठीक है, and it is very obvious why it is 0, because वहाँ पे सपोर्ट्स है तो ड्यू टू बेंडिंग डिफॉर्मेशन नहीं होगा, ठीक है, एंड MC मैक्सिमम वैल्यू विल बी देयर, एंड व्हाट इज दैट, WL by 4, and why, because the load is acting which is responsible to damage, to shear off the beam, ठीक है, एंड सो ये क्या हो जाएगा, ये पॉजिटिव हो गया, नेगेटिव हो गया, सो दिस इज पॉजिटिव, दैट्स वाई दिस वन विथ WL by 4, ठीक है, अब ए भी 0 है, ठीक है, और ये ऐसा क्या ऐसा होगा, नो, ऐसा क्यों होगा, ये ऐसा होगा, नो, वाई, because the variation is linear, ठीक है, तो यहाँ पे आपको पैराबोलिक मीन्स द कॉन्केव एंड कॉन्वेक्स सोचना ही नहीं है, ठीक है, आप देख सकते हैं दिस इक्वेशन इज व्हाट, वेरिएशन इज व्हाट, linear variation, linear variation is there, ठीक है, so that's why it is varying linearly, and it is varying linearly, and both positive, this is your bending moment diagram. So hope you will enjoy it, and in this way I have done. Thank you. So after this, now let us consider the point load is acting at some point, not at the mid, okay, so this is the beam of length L, so at C W force is acting, and from A it is A distance, from B it is small b distance, and the reactions already we have calculated for the considering the point load at the midpoint. After this, what you have to do, the same thing, the taking sections here, taking section here in between A to C and C to B. So this we have shown here. You can see our focus is now this one figure, this one, ठीक है, this is simple free body diagram, and this is free body diagram including the internal forces, ठीक है, इसमें जो भी सपोर्ट्स था, दिस FBD हमने क्या किए, सपोर्ट्स रिमूव कर दिए, दिस FBD including the internal reactions, including the internal reactions, means shear and moment, means shear, force and moment, okay, so this is the same like previously, okay, so now what will be the nature of this, whether acting at a midpoint like a acting at midpoint A, B, okay, or somewhere else, like here. So what we get, the shear force, the nature we know, ठीक है, कि यहाँ से from A to C how it will vary, constant, ठीक है, and C to B ये हो जाएगा, ये नेचर इज सेम, ठीक है, जैसे मीट पे एक्ट कर रहे हैं, तो दिस वी गॉट ना, दिस वी गॉट, ओके, बट नाउ द डिस्टेंस W कहाँ पे एक्ट कर रहे हैं, सो A to C इंक्रीजेस, ठीक है, द span of shear force acting या shear force distribution you can say increases, ठीक है, और shear force का you can say area increases, बाकी तो वही है, नेचर वही है, ठीक है, ये क्या हो गया, ये बढ़ गया, दिस लेंथ गॉट इंक्रीज, ओके, बट दिस लेंथ अभी छोटा हो गया, नेचर वही है, ओके, एंड व्हाट अबाउट द बेंडिंग मोमेंट, तो बेंडिंग मोमेंट का भी सेम वही है, ठीक है, अब करस्पॉन्डिंग टू दिस सपोज सी ड्रॉ द लाइन, एंड ये लेंथ आपका ए है, एंड दिस लेंथ इज बी, एंड एज पर दिस ए इज ग्रेटर देन बी, ठीक है, तो इसका जो है ये हो गया, एंड ये आपका ऐसे हो जाएगा, लेट अस इसको दिस इज बी, ठीक, सो लेंथ मीन्स एरिया of this left side areas of A1, right side A2, this is A1, A2, ठीक है, so A1 increases here, A1 increases, nothing else, चाहे ये weight पे act करे या A के towards A or towards B, and for that the main thing is now the magnitude, definitely magnitude varies, ठीक है, like what will be magnitude of this, okay, what will be the magnitude of this is our worry, what is the magnitude of this, ठीक है, this height, this magnitude and this magnitude, ठीक है, ये हमें जानना है, so on the calculations what we have to do, simply from this free body diagram, ठीक है, whatever you want to suppose you want to get the support reactions, so without cutting the section like this one, ठीक है, the simple free body diagram जैसे हम लोग करते थे उससे we get by satisfying the equilibrium condition, summation of Fy is equal to 0, summation of moment about A 0, then Va plus Rb is equal to 0, okay, so this is our first equation, and the moment about A, so moment about A, and W is acting this W is acting downward, so it will try to rotate clockwise, that's why minus here, and WA it is multiplied by A, the perpendicular distance, and RB, and with the perpendicular distance is equal to 0, okay, so from here equation second what we got, RB we got, and by putting the value of RB in equation 1 we get VA, ठीक है, so what is the here, this is the magnitude, ठीक है, so RB WA divided by L, so this side what, W A divided by L. What about this side? So W B divided by L. ठीक है, मैग्नीट्यूड चेंज हो गया बट नेचर इज सेम. ओके, सिमिलरली द बेंडिंग मोमेंट कैलकुलेशन. सो अब जो नाउ this is with the help of the bending moment diagram by cutting the beam. Okay, so this is the left segment and this is the right segment. Right segment. ठीक है. So क्या किया हमने? Moment about 1 1. This 1 1. Moment about 1 1 is equal to 0. Then M is acting clockwise, that's why positive. Okay, V is acting M is acting anti-clockwise. Okay, so positive. V is acting clockwise, that's why with minus sign, and multiplied by the distance. Distance is this one, x1, perpendicular distance. Okay, so after this what we get? M is equal to WB by L multiplied by this x1. Okay, and this is now we have to satisfy the boundary conditions. So x1 is equal to 0, x1 is equal to 0, that means at A, so MA is 0. Okay, and suppose x1 is equal to A, x1 is equal to A means we are talking about C. Okay, and MC we get here WBL multiplied by A. Okay, so this is the magnitude. We were talking about the magnitude of this watt. So it is WAB divided by L. So in this way we have done. Okay, no need to worry. Nature will be same. Either it acts at the mid or somewhere else. But definitely magnitude varies. So for that again you have to satisfy the equilibrium conditions and you have to get the support reactions. Then based on the cut section free body diagram you have to get the shear force, not bending moment diagram. Okay, in this way we have done. Thank you.